Welcome back to the next video, where in this video we're just going to go through some very standard normal distribution questions, no pun intended, and we are going to tackle these questions. So feel free to pause this video right now to tackle the question. When you're ready, come back, unpause the video, and we'll begin. So let's go through this question. We have an orchid produces mangoes which have masses that follow a normal distribution. So it's very important before we even start doing a question to properly define what is our normally distributed variable. So over here, I'm going to let x be the mass of the mangoes. Okay, so x follows a normal distribution of 190 and variance, right? 30%. So when you see 30% means 0.3, produce are heavier than 220 grams. So what this means is the probability of x being bigger than 220, right? Because this is in grams, so I can just directly quote it directly. It has a value of 0.3. So if we flip it around, lesser than 220 would be 0.7, right? Because, both will add up to 1, right? If I were to sketch out the curve here is 190, here is 220. So if this portion of the curve is 0.3, that means this whole portion here has to be 0.7, right? There's no other way around it. So now, how do we even find out what is this? The way that we do it is we standardize it. We transform this into a normal distribution curve first, okay? And how we transform this into a normal distribution curve is we transform it. So remember, our x variable has to minus the mean value, right? We shift left by 190 first. Remember what we did in the earlier tutorial, and then we divide it by the standard deviation, right? So this whole value here will also shift likewise, and this whole thing here will still be 0.7, right? I'm just going to bring this whole working here. By doing so, we effectively transform this graph down to this graph, and we end up with a new scale, which is z lesser than 30 over sigma is 0.7, where now we know that z follows a normal distribution of 0.1. So what that means for us is when we transform this graph to here, this value of 220 originally on this new graph here is being represented by 30 minus sigma. And the good thing about this now is that we know that this whole area over here is 0.7. So we can inverse norm now to find out what is 30 over sigma from the GC. So from GC, we get that 30 over sigma will have a value of something, right? So over here, we just got to go second inverse norm. Then my area is now 0.7 and it goes to the left, right? Paste, enter. 0.52440 dot 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 dot. So I will come back here. So it's 0.52440 dot 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 dot. Therefore, sigma will be 30 divided by 0.52440 dot dot dot, right? And I actually end up with 30 divided by my answer, second answer, 57.208. So I get 57.208 dot 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 dot, which is 57.2 to 3SF. And here is the final answer to this question over here. Okay, so that'll be it. I'm just going to shift it up here. Okay, I'm just going to shrink it a little bit more. Okay, great. So that's it for this question. Now, feel free to pause this video right now to tackle the next question over here. And when you're ready, come back and let's go through this over here. Okay, so now let's start the next question. Feel free to pause this video right now to try this. I know it might seem a little bit abstract, but I promise you it's the same concept. So when you're ready, come back and let's do this question over here. So once again, we have this curve and a normal distributed curve with a continuous random variable called x and a curve that looks like that originally. And by here, this is the mean value and the standard deviation is theta, right? Now, if we want to find out what is p, x is lesser than or equals to the mean plus 2 of this. So how do we use the idea of standardization to help us solve this question? We can transform this to give us this, right? Because now what we want to do, let's say here is this, right? We effectively want to find out what is this whole area under the graph over here. So what we can do is to standardize the whole graph to become a z curve, right? Whereby here is 0 and then here will be some new value now. So how do we standardize it? Again, all the x values, we shift left by the mean value, we divide it by the standard deviation, right? Plus 2 originally, then I minus away this, then I divide by this. So in the end, I get a z curve. So from here, I have just standardized it, right? I have standardized the x into a z by shifting everything to the left by the mean value and dividing it away by the standard deviation. So over here, you see that these two cancels out, then this one will divide away this, right? So I end up with 2. So now you see that from here, when I standardize into this value becomes 2, but the area under the graph remains the same. So now, what's this area? Then I simply just got to key into my calculator, right? Normal CDF, area is 2, sorry, upper is 2, paste, enter, 0.797724. 0.977249 dot 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 dot. So I get 0.9782, sorry, 977. 2, 3s left. And that's the final answer over there. Okay, so that'll be it. Last but not least, we have a question over here. Feel free to pause this now to tackle this question, and when you're ready, come back and let's break down this question together. Right, so let's take a look at this question over here. And again, we have the time, right? So now the continuous random variable is time. So we're first gonna define it. So let x be the time taken by students on their math tutorial. Okay, I mean, it can be phrased a little bit better. So x follows a normal distribution of mean and variance. 5%, 0.05, spend less than 40 minutes. So from the first sentence over here, we get that when x is lesser than 40, I get a value of 0.05. And then from here, I get 60% of them. So this is 0.60, spend more than 1 hour, so 1 hour is 60 minutes, right? So note that this x value over here is in minutes. So I get that when x is bigger than 60, I get a value of 0.6. So now we want to find the values of this and this, correct to 2dp. So once again, how does it look like in practice? I have a normally distributed curve. Here is the center, the mean value, lesser than 40. So let's say here is 40. This value over here is 0.05. More than 60. So let's say more than 60. This value here is 0.6. So this is what we have so far, all the information, but we don't know what is the mean or the variance yet. But what we can do is to standardize this graph so that our parameters become known values. So we can standardize both equations here. I minus the mean, I divide by the standard deviation, right? The area on the graph will remain the same. Same thing here. Bigger than 60 minus this over this, 0.6. So in the end, I get Pz lesser than 40 minus this. This is 0.05, and Pz is bigger than this is 0.6. And of course, if it's bigger, we cannot key this into our GC. So what we'll do is that we'll flip it, right? It's 1 minus 0.6, right? We take the complement, so it's 0.4 here. So from here, we get these two equations that now uses the standard curve of z follows a normal distribution of 0, 1. So in practice, now we have a z curve, whereby here, the mean value is 0, and here is 40 minus this divided by theta, whereby here is 0.05, right? And then here, this is 60 minus mean divided by standard deviation, and this whole value over here is 0.40. So now, how do we find out what are these two values? First, before we find out what is the mean value and the standard deviation, we will inverse norm, right? Because we know the areas associated. And apologies, this is not 0.4. Just realize this whole area over here, right, is 0.4. So from this equation over here, right, from GC, I get that 40 minus this divided by standard deviation will give me a specific value. And all I need to do is to come here, DISTR, inverse norm, 0.05. You got to delete this, delete. So I click enter, I get negative 1.6448 ... right? That's essentially the value that I get over here. Then again, 60 minus this over this. So from here, I just got to go back to my calculator, again, inverse norm, but now the area is 0.4, right? So inverse norm, and the area is 0.4. Enter, I get negative 0.25334 ... So you see, now I have two equations. I have equation 1, equation 2, and I have two unknowns. Unknown. So when you have two unknowns and two known values, this is where you can use simultaneous equations to solve, right? Because from here, 40 minus the mean value is negative 1.644 ... standard deviation, right? And then from here, I get that 40 plus 1.644 ... standard deviation equals to this. And then I can start this into here. And that will give me 60 minus bracket 40 plus 1.644 ... standard deviation over standard deviation is 0.2 negative 534 ... right? And then from here, you just need to solve for the standard deviation. So I'm just going to fast forward this step because it's quite long, but I'm sure that as a JC student by now, you should be able to solve it. And alright, so if both of your answers were correct, you should have gotten these two values over here, 6.63 and 14.4. Okay, and with that said, we've come to the end of this video over here. If you got any other questions, feel free to, apologies, I just saw the answer to 2dp, right? So if the answer is indeed to 2dp, that means this would be here to 2dp, and this answer over here would be 6.4 to 2dp, right? And that will be all for this question over here. Apologies, yeah. The answer is to 2dp, so these are the answers over here. Okay, any other questions, feel free to reach out through WhatsApp or leave it in the comments below, and I'll see you in the next video.